Hi friends, in the previous video we discussed about some basic introduction to thermodynamics and few terms related to thermodynamics. In this lecture we're gonna continue with the basics of thermodynamics only and we'll understand few more terms. What are those terms? First we'll go with the state. What is the state of the system? Then we'll go for equilibrium system state. What do we mean by equilibrium state? Then we'll go for the processes. What do we mean by process? So let us first start with state. So what do we mean by state? State is the condition of the system at any particular instant of time. किसी भी सिस्टम का किसी पर्टिकुलर इंस्टेंट ऑफ टाइम में जो भी सिचुएशन है, उसका जो भी कंडीशन है, वो उसका स्टेट होता है. So it means that if I know the state of system, I can tell you what is the pressure of the system, what is the volume of the system, what is the temperature of the system. Any thermodynamic property I can tell about the system if I am telling that I know the state of the system. अगर इसको अपन एक एग्जाम्पल से समझते हैं तो अगर इफ़ आई एम टेलिंग दैट कि मेरे को किसी पर्सन का स्टेट मालूम है, इसका मतलब क्या है, मेरे को उस पर्सन से रिलेटेड सारे डेटा मेरे पास अवेलेबल है. अब वो डेटा क्या क्या हो सकते हैं कि वो कौन से कंट्री के, कौन से स्टेट के, कौन से गांव में रहता है, ये भी मेरे को पता है. वो अभी क्या कर रहा है, खा रहा है, पी रहा है, टीवी देख रहा है, ये भी मेरे को पता है. टीवी देख रहा है तो कौन सा चैनल देख रहा है, ये भी मेरे को पता है. और उसने कपड़े पहने हैं नहीं पहने, और पहना है तो कौन सा कलर का पहना है, सारे डेटा मेरे पास अवेलेबल है. देन ओनली आई कैन से दैट आई नो द स्टेट ऑफ दैट पर्सन. उसी टाइप थर्मोडायनेमिक सिस्टम का अगर मैं सारी थर्मोडायनेमिक प्रॉपर्टीज बताने के लिए कैपेबल हूँ, if I know each and every property of the thermodynamic system at any particular instant of time, then only I can say that I know the state of the system. So if I know all the properties of the system at that particular instant of time, then I should be able to plot that property, plot that state in the property chart. अब property chart क्या होता है? Now property chart is just a coordinate axis in which x axis is represented by some other property like volume, pressure, it can be anything, and in y axis there is some different property like temperature, volume, pressure. So in the example I have generalized the chart as x coordinate, it can be volume, it can be pressure, and y coordinate, it can also be volume, pressure, anything. Now if I know the volume and suppose it is PV diagram, that is y axis is pressure and x axis is volume. So now if I am telling that I know the state of the point and I am telling that it is state number 1, so I should be able to tell you what is the volume of the system at that point and what is the pressure at that instant. So obviously we can plot that in the pressure volume chart now. So we can locate one state, whatever volume and pressure it is there. So now as the time passes, it is not that the state is not gonna change. It may change, the volume may change, the pressure may also change. So it can be at that instant of time in any other state of state. So I should be able to represent that state also in the property chart if I know, if I am telling that I know the state of the system. So suppose it is at 2. So this is how we can plot any state of the system in property chart. So this was all about state. Now coming to equilibrium state. Now what do we mean by equilibrium state? Equilibrium state means the system do not want to change its state until and unless some external effort is applied. So some external driving force must be there for the system to change state from 1 to 2, say. Now what is the driving force? It is not just mechanical driving force, it can be heat also, thermal driving force, it can be certain chemical reaction also. So something must be needed to apply so that the system changes the state. So that kind of state is called equilibrium state. अगर इसको एक फनी एग्जांपल के तरीके से समझा जाए तो इक्विलिब्रियम स्टेट एक सख्त लौंडे जैसा है. जब तक उसको सामने से इंडिकेशन नहीं आएगा वो कुछ भी करने के लिए मोटिवेट नहीं होने वाला है. सो अब इक्विलिब्रियम स्टेट, हाउ वी कैन टेल दैट द सिस्टम इज इन इक्विलिब्रियम स्टेट और नॉट. सो फॉर द सिस्टम टू बी इन थर्मोडायनेमिक इक्विलिब्रियम स्टेट, it must possess 3 different equilibrium conditions. One is thermal equilibrium, second is mechanical equilibrium, third is chemical equilibrium. If the system is in all these 3 equilibrium states, then only we can say that the system is in thermodynamic equilibrium. Now we'll study this one by one, right? So what is thermal equilibrium? Thermal equilibrium means if we consider the system, there cannot be any transfer of heat from one part of the system to another part of the system, or if we are telling that the system and the surrounding are in thermal equilibrium, it means there can be no heat transfer from system to surrounding and surrounding to system, even if we apply the conducting boundary. So what do that mean actually? अगर कंडक्टिंग बाउंड्री है फिर भी हीट ट्रांसफर नहीं हो रहा है, इसका एक ही मतलब है द टेम्परेचर शुड बी सेम बिटवीन surrounding and system, or system A to system B, whatever we are talking, the two in equilibrium. So if you understand this with an example, I have drawn a container. In this, the container is divided by a conducting piston. Now in the A side and B side, both side I have air with suppose temperature T1 and T2. Now as the partition is conducting, and if the temperature difference is there, suppose T1 is different from T2, obviously they are gonna transfer of heat from higher temperature to lower temperature. So we cannot say that the portion A, partition A and partition B are in thermal equilibrium, because heat is gonna transfer from B to A or A to B, whatever be the temperature difference. So if T1 is equal to T2, and then again if the partition is conducting, then also there will be no heat transfer, because अब टेम्परेचर दोनों का सेम है तो हीट ट्रांसफर होगा कहाँ से? इट कैन नॉट हैपन ना. So if when we are able to say that the system is in thermal equilibrium, that whatever systems we are considering or system and surrounding we are considering, the temperature difference between the two is zero, then only we can say that the system and surrounding or system A and system B are in thermal equilibrium. So this was all about thermal equilibrium. Now coming to mechanical equilibrium. Now what is mechanical equilibrium? Mechanical equilibrium simply means summation of net external force is zero and net movement is zero in the system. So for mechanical equilibrium to be there in system, these 6 conditions must be followed. Summation of fx equal 0, summation of fy is equal to 0, summation of fz is equal to 0, summation of mx is equal to 0, summation of my 0, summation of mz 0. That is, forces in the all 3 perpendicular directions, the net force is 0 and net movement about any of the axis, any of the 3 perpendicular axis is also 0. Then we say that the system is in mechanical equilibrium. So let us take one more example. Actually we are taking the same example for the mechanical equilibrium analysis also. So what we have changed in the example is that the piston, instead of it is conducting, it is now movable piston. Now it can freely move from left to right or right to left, and it again separates the 2 gases in the container A and B. Right. Now if the pressure on the A side is P1 and pressure on the B side P2, if these 2 pressure P1 and P2 are different, obviously there gonna be net force on the piston either from left to right, from A to B or from B to A. And if the piston is able to move freely, obviously it will move also. So in this case what is happening? There inside the system there is certain point where unbalanced force are there, and there are possibility for the movement to take place. So we will not say that the system is in mechanical equilibrium. Now if suppose I am telling you that P1 is equal to P2, will the piston gonna move? No, it cannot move, because there is no external force acting on the piston so that it can move. So this kind of system in which there are no external force is applied, no net force is there, no net movement is there, then we say that the system is in mechanical equilibrium. So this was all about mechanical equilibrium. Now coming to chemical equilibrium. What do we mean by chemical equilibrium? Chemical equilibrium means simply that the composition of each chemical component in the system remains constant with the time unless and until we apply certain extra effort for the reaction to proceed or something to happen so that the composition changes. So let us understand this with also an example. Suppose I have 2 chemical components A and B. I mix them together in a beaker and let the reaction to take place. After certain time interval, the composition of the A and B will combine and will give C and D. But in the beaker, all 4 will be there: A, B, C and D. That is, and after the time, after that time, the composition, that is percentage of A, B, C and D in the solution is not changing. So such kind of situation are said to be in chemical equilibrium. Now what is taking place? अभी क्या reaction नहीं हो रहा है? Actually reaction is taking place, but the thing is that जितना अमाउंट A और B कंबाइन होके C और D दे रहा है, उतना ही C और D वापस से कंबाइन होके A और B दे रहा है. दैट इज द रेट ऑफ फॉरवर्ड रिएक्शन in this case is equal to the rate of backward reaction. So reaction is taking place, but the net result is remains constant. The net, there is no change in the net composition of the each components. So this was about chemical equilibrium. So if all these three equilibrium exist together, like thermal equilibrium, mechanical equilibrium and chemical equilibrium, then only we are able to say that the system is in thermodynamic equilibrium. Now coming to process, what is mean by process? Process is the way through which system can change its state from say 1 to say state 2. It means that ki if I suppose I have my system in state 1, as I shown in the example in the property chart, XY chart, I have my system in my state in initial state 1 and I want to go to final state 2. So I can either go through path A or path B by following. So by following path A and path B. So these are the two different processes. These are the two different ways through which I can reach from state 1 to state 2. अगर इसको एक एग्जांपल के साथ समझा जाए तो सपोज आई एम इन बेंगलोर, मैं बेंगलोर में हूँ, मेरे को सूरत जाना है, तो मैं कैसे जा सकता हूँ? पहला, मैं सूरत के लिए डायरेक्ट फ्लाइट ले सकता हूँ. दूसरा, मैं मुंबई तक यहाँ से फ्लाइट लेता हूँ, फिर वहाँ से सूरत के लिए ट्रेन लेता हूँ, या यहाँ से सूरत डायरेक्ट ट्रेन लेता हूँ. सो दिस आर द फ्यू डिफरेंट वेज थ्रू विच आई कैन रीच फ्रॉम बेंगलोर टू सूरत. सो दिस आर द थ्री डिफरेंट प्रोसेसेस विच आई नीड टू फॉलो सो दैट आई कैन रीच फ्रॉम बेंगलोर टू सूरत. सो यही होता है सिस्टम का प्रोसेस भी. किसी भी सिस्टम में अगर प्रोसेस हो रहा है, इसका मतलब उसका कोई इनिशियल स्टेज है 1, फाइनल स्टेज है 2, वहाँ तक पहुँचने के लिए जो पाथ फॉलो कर रहे हैं, तो जो वे फॉलो कर रहे हैं, जो जिस तरीके से अपन जो प्रोसीजर फॉलो कर रहे हैं, वो प्रोसीजर को अपन प्रोसेस बोलते हैं. नाउ व्हाट इज रिवर्सिबल प्रोसेस? रिवर्सिबल प्रोसेस इज द प्रोसेस विच द सिस्टम फॉलोज in going from state 1 to 2 so that we have information related to all the intermediate equilibrium states the system has followed. इसका मतलब क्या होता है? अगर अपन प्रोसेस ड्रॉ करते हैं, सपोज आई हैव अ XY चार्ट, okay, and we are plotting two states 1 to 2 and we want to go from 1 to 2 and we draw corresponding process for the same. Now if I just take a look at the small segment of this process, suppose I have taken this small segment and I zoomed it. So in this small segment also there are infinite numbers of points and I know the information of all the states related to these points. Then only I say that my process is reversible process. अब बात करते हैं कि ये प्रोसेस रिवर्सिबल प्रोसेस रियलिटी में होता है कि नहीं. एक्चुअली रियलिटी में कोई रिवर्सिबल प्रोसेस नहीं होता है. इट्स जस्ट अ imaginary process used to compare other process. So this was about reversible process. Now let us come to irreversible process. Irreversible process is the process followed by system in going from state say 1 to 2 so that we do not have any information regarding any of the intermediate equilibrium state. So let us take one example. I have a piston cylinder arrangement and above the piston I have kept one block. Now if I just remove that block, what is there? There is a pressure difference between the piston from upside and downside. Downside is higher pressure. So what will happen? The piston will try to go up and it will settle down at certain other equilibrium position so that the upward and downward pressure are equal. Now what has just happened? As I remove the block, the piston suddenly moves up and settle down at certain position. So I have the information regarding the initial state, I have the information regarding the final state, but I am not able to measure the properties of the system at the intermediate states. So such kind of process are called irreversible process. Now since I do not know what are the properties of the system in between the two initial and final states, so I should not be able to draw any curve representing the this particular irreversible process. So what we conventionally follow is we just draw a dotted dash or dashed line from initial stage 1 to final stage 2 so that it represents the irreversibility of the process. So it means that irreversible process is represented by a dashed line starting from initial stage say 1 to final state, state 2. So this was about irreversible process. Coming to quasi-static process. Most of us confused with this quasi-static process with the reversible process, because we are able to draw this quasi-static process in the property chart. So what is actually quasi-static process? Let us take the same example what we have taken in the case of irreversible process. We have a piston cylinder arrangement, and above the piston I have kept one block. Now suppose I have divided this block into so many small infinitesimal particles. Now what I am doing, I am just picking one particle and remove it. So what will happen? The piston will slightly move up and settle down. Then I will again take the second particle and remove it. The piston will again move up and it will again settle down. So what I am doing, I am reaching from state 1 to 2 in certain intermediate steps. So what benefit I am getting from this is that I am able to note down the information regarding the equilibrium state which the system was there in the intermediate states also. So if I try to plot this whole process in the property chart, what will happen? I have initial state, I have final state, and in between whatever intermediate states we just stopped at, we also measure the properties of the system at that point. So we are able to plot that points also. Now we have rough idea of the process of the path which the system has followed in going from state 1 to state 2. So I can draw a line which joins all these intermediate points to reach from 1 to 2. So in this case, quasi-static process is actually tends to reversible. It is not reversible process, because in reversible process we have information regarding all the points. Between these two intermediate points, states, what is happening we don't know. The process which follows from going from this intermediate state, say one state A to state B, intermediate state, second intermediate state. So the process the system has followed in going from this to this is irreversible, because we have just removed the particle and the piston has moved in a manner so that we are not able to get information about the intermediate points in between these two intermediate points. So but if we consider the overall process from 1 to 2, we are able to draw an tentative line the system has followed in going from 1 to 2, and we say that the system is in quasi-equilibrium process. The system has followed the quasi-equilibrium process. So in this manner, the quasi-static manner can be assumed to be reversible, but it is actually not reversible. This is the bottom line. Quasi-static process is not reversible process, it is assumed to be reversible process. So this was all about the processes. These are the three types of process, that is reversible process, irreversible process and quasi-static process. Thank you, and if you like the video, please press the like button and please do subscribe if not done yet, so that my videos can easily reach to you. Thank you.